Okay, a little bit of a late night stream. I just had some free time and I thought I'd clean up the code. So let's get started. I want to move to the SDL main, which is a new thing that they've done with SDL 3, where SDL 3 main, which instead of us having to write the main, they write main for us. And all we have to do is use these callbacks to set things up. So app init, app event, app iterate, and app quit. So there's a big readme for it, and we'll go through that. So yes, if you're using something like Windows and stuff, SCL has a bit of issues. It needs a win main on Windows, for example. So yeah, instead of having all of that glue code and trying to set up things, instead we can just use the callbacks because it is to a certain extent how SDL is supposed to be used. I'll also refactor some of these, but we'll come to that later. Define. So yes, we need main use callbacks. In a single source file, might as well be the main source file. Put this right above the SDL line, right? It will be used internally. It has to be a define, unfortunately. So once that's done, we don't want the main because this will actually cause troubles. So for example, build worked. That's unique. Okay, I mean, that's nice, I suppose. It's because I have the wrong file around here. We'll get the stl.h as well, but we'll keep main. And you can see this is an error. This is an issue now. So we'll copy the 4 different files that they have. We'll go back to this one. App init, app event, app iterate, and app quit. Just copy the text. Just close that down. Paste. Okay, each of these returns an app result. Sorry, this is the wrong one, but app init. And it needs to return app success. No, it needs to return app continue. Anything else is a failure, is a discontinuation, not a failure, just a discontinuation. So it's the app init. This gives us a state pointer, which is a void pointer as it normally is. So there we will put our required state. argc and argv, these are the normal main function. Oops. Normal main function inputs. App event gives us an app state. Since it expects us to have created app state in app init, here we will only get the app state, sorry, and the event, while iterate will give us the app state. The order of these is different from the order of the declarations that we had before. So yeah, void pointer app state. We do nothing with that. SQL app result quit also gives you an app state. We do nothing with that. Oh, it does have an SDL app result. When we're terminating, it will give us an app result check. So we will. Something is wrong with this. Quit is void, doesn't return result. Okay, so that's the D init. Function will be called no matter what, so no problem with that. Should deinitialize any resource necessary, perform shutdown activities, and return. You do not need to call SDL quit on this function. SDL will call it after the function returns, before the process terminates. Okay, and do we need to call SDL init? So main callbacks. Once that is done, high level if defs, using the callback entry points. Okay, anyway, this was our main. We don't have it anymore. SDL init, I suppose, still has to be run. So we will do that. Or we can check SDL app init means SDL init. Callback should not go into a loop. One type setup and return. If it returns continue, go on. Nothing else is said here. Init. Is it okay to call SDL init? No answers. It's all right. We will leave it as it is and see if there are any errors. If there are, then, well, we know there are errors. Next is Volk to be initialized. In fact, we will initialize Volk before we initialize STL. Next would be the window, which has to be saved somewhere. So we'll have to create a struct. Struct app state. Let's just call it app state. Window pointer window. So app state here. I'm doing malloc, but you know, it can be something else if you use allocators and stuff, which we should, but not right now. And I will actually allocate right now, actually. How many times have I said actually? Local memory. It's just a linear allocator. And that's that. This can be a cost. Since we have an init, we also need a destroy. So shut down. So many possible names. We just have to check the memory once. Everything else can handle itself. We will also make a little convenience macro. It is a macro because it will be easier for us to use, but it doesn't necessarily have to be. All take does is it removes a value and return and stores an empty object there. So something like it's the memory would actually be replaced by a null pointer when we do this. Can be quite useful every now and then, and we can do that here as well, right? We're not going to because it's fine to say it's equals zero, or in fact we can do that manually every time. It's more transparent. If not memory, so if it's already been deinitialized, then we just return and do nothing. We don't want to double free this thing. This one will be a null pointer. And that's init and shut down for memory. So we can just start here and we can say memory, and we want it to be global. So the memory in reality it doesn't have to be here, it can be an app state. Yeah, let's just allocate app state and have it allocate other memory internally later. So fine. Currently we don't need any of it, so malloc app state. So app state, and that should malloc itself to cast it. So that is done. State hides a local declaration, of course it does. So we will change that to p app state, which is very welcome. And we will assign the app state. So p app state. Okay, app state. I'm not doing the double, so I'm not going to use the double void pointer directly because it's easier for me to just use a single pointer. However, app state has a window, so this window actually will go to app state. We will first check. So if not window stl dot error categories stl category What category is this? I'll call it application category. Why not? Okay. So that does it for the window, followed by app state window. Get error, and of course, if it gets error here, then STL failure as an app result, and we quit there. So that's window. I'm not going to verbalize every single thing I do because a lot of it is relatively mundane. Even for app state, I would like to actually do something like that. So it's followed by this cannot be added there because it is in fact a void word pointer. But it would be here. That looks like an appropriate set. So we can use references instead of pointers. To be fair, they don't make that much of a difference. It's just syntactically, it's always a dot, and references cannot be null. So having a reference implies that we have done null testing on this particular thing. We comment in there. And let's see if it actually does what I expect it to do. No, it does not. Let's create instance. That is create surface. Okay. And we can do here possibly move this entire initialization outside as a function of the render device initialization itself. So we have a like a init function here, and start from there. What are the words we're using? Init and shutdown, init and destroy. I don't know. I like destroy. I'm gonna keep destroy. Cleanup. Init and cleanup. Fine. So init device has a cleanup. Init device has a init. We can move this into init. The definition. Create instance. That this will automatically work itself out. Surface. You can see we're making an assumption here that you're given say subsystem, like the renderer subsystem. If it fails, it's fine. Like we just crash. So I'll write that down. That's instance. Something happened here. Can't figure why, but something seems to have happened there. Anyway, we can copy paste most of this all the way down until pipeline layouts. That is obviously not a part of the renderer itself. Okay, some of these things will have to be moved into the struct here. So we'll see which ones. Create instance, create surface, create class, and queue. So both, all of these will have to go up there. I could use default initialization there, but actually let's leave it in. So we got the default initialization, no pointer, pointer. Not sure that leaves this as a pod though. So assert std is trivial render device. It's not trivial anymore. But if I remove this, it probably will become trivial. What are the benefits of trivial types? You can just copy them around and nobody cares, right? So this is purely memory. I can read, write, save it into a file and reload it within a single run, and it would be fine. Of course, the moment we move the vectors into the big struct, everything will start falling apart. See? Soon went off. 100. There you go. This is simply because vectors have constructors assigned to them. I will move this, copy, remove that. Search for swap chain. Paste that there. So that should get its job done. Vector images don't work because we don't know how many swap chain images we're going to get. What I will do, however, is say images and size. So size t in image count and vk image view. This actually could be uint 32t. We don't need that because images and views both have the exact same number of counts, same number of elements. Go to init. The swap chain image count is a shadow, so we will probably remove it, let it use it here as a random value, and then we actually use it there. This becomes a malloc. Multiplied by size of vk. Really don't need to do that. Swap chain images. Right, so this is the size of one swap chain image, and that is the count. This has to be cast, so done, and this becomes a direct system. Flip the star arguments, it says. Done. Bug prone. Into that. Uh, Fine. VK swap chain. It's actually VK image. Now it should be okay. This malloc, we will eventually come back and remove it, but for now it's fine. Swap chain images, we cannot do for each on it anymore. That's not nice. Pretty span of swap chain images and swap chain image count. We can have it just iterate over that, and that will be fine. Again, these allocations, it cannot be malloc. I mean, it's fine for it to be malloc, but ideally it shouldn't be malloc. So if you're going to do custom allocations, it has to be written down. but it's fine for now. Swap chain views equals static cast image view pointer malloc size of image view and swap chain image count. Right, so that's swap chain image views right there. Once that is malloced, just inside for each, we can swap this back. So for in I equals 0, I less than or not equal to swap chain image count plus I. Image is now replaced by swap chain images I, and instead of pushback, we will write it. So I here, that, that, and take that address. One of them is U32, the other one is we can leave it to not equal to. Just change this to UN32T, and it should be fine now. Okay, these mallocs are currently problematic, as in not really problematic. This is not really a hot path. We don't particularly care, but it's something we ideally do not want to deal with. Anyway, so respectively, there should be a cleanup for this. Let's collapse. Oh wow, the collapse isn't working. How fun is that, huh? Let's create the destroy function for this. So the corresponding destroy would be surrender device, cleanup. There we go. And we need to copy paste everything from the cleanup side of things. All of that is fine, right? All of the pipeline and everything, we leave it where it is. Okay, here. Volt finalize, surface, pipelines. So until swap chain, and we have these image view, which is in the wrong place right now. So image view, swap chain, come down to Volt finalize, and all of this should be a part of the cleanup. Okay, so this is done. What's your problem? Const is the problem. Swap chain image views cannot be for each anymore. So this is the thing. Like, this is a decision we need to make now. Are we going to use standard allocators like STL and all of that? Or are we just going to create malloc arrays, or if not malloc, but use custom allocators to create them? And this is something I always struggle with. You can write code that looks like C, works like C, but is written in C++ and can use some of the features like member functions and overloading, but not all of them. So you don't use virtual functions, you don't use classes, or you write as if it is, you know, C++ completely, and you just use spans and vectors and everything. That does become a question to answer. In this case, we have image and image view here, of which are just pointers with a single count down there. I think I'm fine using the count, so the for each can be removed in the cleanup, right? So this you cannot do. Why is this compiling? I mean, is it compiling? 4 bytes padding added is a warning. We'll look at that later. Enable device size, yeah, that's fine. There we go. It isn't compiling. That's completely fine, right? So for UN32. e on zero or not equal to swap chain image count plus I, and the view just gets replaced by swap chain image views I, right? Okay. Once this is done, we also need to free the array itself. So free swap chain image views and set it to null pointer just to ensure that there's nothing left there. So the images will be cleared up by by Vulkan itself. So we just need to free the array, which is so images equals null pointer, and we're done with that. In equals null pointer. So this is why I wanted take, right? So let's actually bring it back. But instead of just bringing it back, I think I'll write it as a function. Auto take auto value ampersand ampersand. So we have a move constructor there. Not constructor, but like we can take a value by move. We can take any kind of value we want. This is followed by auto x equals value. And you know what? STD exchange. We'll just use exchange. This one is STD forward. So we have to do a forwarding here. Tackle type of value. This looks like monstrosity, like an eldritch monstrosity, but it is what it is. What we're doing here is taking the type of this value, we're forwarding that type. We're taking the value from here, we're giving it to exchange. What exchange does is it takes a different value, in this case, this thing in the braces here. It exchanges this, so this new value goes into the container that we passed in, and the container's value gets returned out. So this will be a return. And this is a function, this is not a macro, right? We could write it as a macro and it would probably be a little easier on the eyes, or like the C programmer's eyes, more like. But for us, it's all the same. And the benefit of this is you can just do take, swap chain images, and that's it. It will pass itself to free properly. We don't have to think too much about it, right? We can do it for a per swap chain image here, but I think that's a bit superfluous. In fact, all of this is relatively superfluous because we can always zero out this entire struct when we're done. So you'll see me do these kind of things where I show something, then I remove it because I don't want to use it personally. And that's a decision I only make after I finish doing something. So yeah, clean up, you can keep it const. So that's the interesting thing, right? It says you can actually have the cleanup be const. Of course not. So if I'm putting in take here, I'll do that off screen. Right now, I just want to clean up in a way that is visible for people in what we're doing, just to keep an ongoing track of how the code is architected. So SDL quit will be automatically handled. We don't care about that. Destroy window is something we do need to move. So let's take app state, right? This needs an init as well. So void init and destroy. So clean up, clean up. This constructs the app state. This is a quit. So it has to destroy the window. Or in reality, it will take the app state, right? This one again, the app state here. I will convert the p app state into actual app state. So app state ampersand app state equals dereference of p app state, which is static cast to app state pointer, right? That's app state, and this would just do app state dot cleanup, and then we free app state. Of course, app state is not a pointer. The app state, you can free that. Not necessary. This memory will be winked. So winked out as in this memory will just soon disappear, and there's no real reason for us to actually clean up after it, right? Everything it owns will also just disappear. Anyway, so moving on, the app state as an init and cleanup now. The app state init also requires an init function, so we will do that. 1 second, Vulkan initialize. We moved Vogue finalize into render cleanup. So Vogue initialize will go into the render init. Has to be at the top. And so next order of operations is to create pipelines, then command pools and everything. So again, pipelines are effectively resources for us, right? They're not actually resources, but they're GPU objects. While command pools are per frame resources that we'll be using. So based on that, we can separate them later on. Right now, I'm not going to pay too much attention into this. So at this very moment, I'll just leave these out in the open. Of course, the location of this whole thing will change, but otherwise it'll be roughly the same. Now, we're still doing the setup. So one of the things in app state init, which hasn't been created, to generate the definition, we first have to create the window. This whole thing gets copied, right? And this window actually gets replaced with the built-in window, like the internal window. Not, then this returns a failure. So this we can actually just do right now. Do a Boolean. App state can either pass or fail, right? So return true. State init, bool, and if not app state dot init. What happened to the intent? Return STL app failure, right? If it did not initialize, we have a problem. Once you're done initializing that, also initialize yourself. So render device dot init, and we pass in the window. Oops. Similarly, cleanup, generate definition, STL destroy window, gives it a window, and before that we clean up the render device. So that's the cleanup function, which will go inside STL app. It's already done. We've hooked up the cleanup there, hooked up the init here. It's initting everything we might need to init. Okay. Memory is being allocated on the fly at the moment, but we'll get there. And all control paths return a value, return and this should be false. Okay, done. So we're doing init here, we're doing finalize there. We have a cleanup here, which also does its own init and finalize. We need to ensure that these are all in pairs, but we can look at that at a later time. All of these other resources, I will currently just pile them into a different structure and ship them out like that. So struct misc data. So all of this needs to be cleaned. Array of command pools, which is array num frames anyway. So, you know, okay. Looking at this, looking at how nicely we can get the automatic iteration, perhaps it is worth it to have STL for all of this, right? So command pools, for example. So in a similar fashion, I think I will leave in vectors for these, okay? And the allocators that we will use will have to be from other templated allocators as well. We have nice ones like that. But anyway, this will automatically lead to errors, which we can fix by just asking for the creation of this. So swap chain dot resize, swap chain image count, and this becomes dot data, right? And similarly, this here gets converted to resize, swap chain image count, and we let it iterate over. This will be reserve. We can do it that way. So we do reserve here. We are effectively undoing everything I've done so far. So that's a bit of a bummer. But sometimes this happens. Decisions are made on the fly, and you realize that your old decisions weren't the best. So you do new decisions or new mistakes. What is life without mistakes, right? Back, view. Reserve has a little bit of a problem. You shouldn't be using it if you're going to continue growing things. But in this case, since we know the exact number, we will never be pushing in more elements. It's a one time allocation. And so reserve is fine. It will be exact. It will be exactly what we need. Resize is similar in the thing that it will actually allocate more than required sometimes, but we'll let it be. It's a one time overhead. It's not that big a deal for us. Again, the views are auto. So auto and view, swap chain views, and we can just let it take the view here. Take the view. Const, of course. Now, once we have rolled back on that, we can start doing the rest. The command tools are here. Command tool create needs to go into the init from this data, so void init, and any init comes with its own cleanup. So void misc data init, right? And let's see what's here. That's pipeline creation. So this needs to be moved. Yeah, it's pretty big, but all of this needs to be moved into the init function here. Okay, so this is just fine. It asks for a device repeatedly. So the init function will actually take the render device as a parameter, and we will take vk device as a shortcut. Device equals render device dot device, right? What's it saying? Can we move to the inner scope? No, it can't. It's fine for right now, but we will add extra code. Swap chain format, again, another thing from the render device. Render device dot swap chain format, and that handles itself. So that's pipeline creation. Command pool, again, command buffers has to be moved into the structure. Oof, this is pretty long. I can't even shrink it. That sucks. Command buffers have been moved. Now command pool create, command buffer allocate. Both of these can be moved into init right there. Direct queue is again render device dot direct queue family index. Semaphores, similar thing. We take this semaphores, we move it there. What a long piece of pipeline creation code, huh? All of those are fine. We move this into the misc data up there. I'm keeping them a little separate from the rest. Not all of these are the same type of things. Because it has no init of this particular type expected. So we can't make it happen. Frame and use fences, no, we don't care about that. Pump events and all of this will automatically occur. We don't have to do it anymore in the new version. We need these structures. As you can see, these are fairly standard looking structures. They don't necessarily need to be global or local, I mean, but because they keep changing on a per frame basis and we cannot necessarily track if we are using it on the correct set of uh, frames, it is better to have these kept aside. Not kept aside, what's the word? It's better to have these kept inside objects so we can track where they are and we don't access them globally from something outside, right? And what we need is these four words. So render to present dependency, render to present barrier. Oops. There's image to acquire dependency and image to acquire barrier. Image to render, sorry, acquire to render. So we move all of these into the struct right here. Image memory barrier 2. Render to present barrier is also the same. It's an image barrier. Acquire to dependencies, okay, dependency info, which we replace here. And that gets us all of the memory buffer creation things. Okay. What else is left? So nothing before we start, which is good. But once we finish, we do have work to do. So all of these are a part of MISC, miscellaneous. So we will add the code to miscellaneous, CleanUp, generate definition, paste it, and we can see what's the issues. So it needs device. So we can ask for rendering device in the CleanUp. Render device and pk device const device equals render device dot device, right? That will automatically handle the rest for us. This is asking for constants. We will add constants. And we can let that continue from there. No member name cleanup. With this, we can change the function signature. Resharper is pretty nice like that. And the device can be a reference to const, so we will do that. This is a reference to const. Init also can be a reference to const, and we're good to go here. Let's see what's up there. So now device wait idle has no place. It should in fact be something that happens at the cleanup here. However, saying that it's something we need to do before misc data cleanup would not be correct. So in reality, it is actually something we would do at SDL cleanup. So app info cleanup actually. So app state cleanup. So misc will be a part of app state. Here we're freeing app state. Here we're cleaning up app state. But first, before we even start with the app state, after we're done casting it, we will say app state, or we can actually do this inside app states cleanup itself. Oh no, this is wrong. We can say render device dot wait item. This doesn't exist. Create member function. There's no problem with that. We can again create member function, generate definition, and paste that there. Okay, so wait idle is a constant function. We don't actually need it to be non-constant. That is enough. That will create what we want. And we can wait for idling. Great. Next step. All of this is a per frame thing. And we've already moved all the cleanup, so just this needs to be cleaned up. We copy all of that. You can see the frame index needs to be added somehow, but we can do that afterwards. Misc state, we don't care at the moment. We will add this, and that's a whole lot of errors. Completely fine. First, app state is statically involved. So the app state like that. Static cast. This one goes away, and we got app state. Okay. Then for rendering device, render device equals star, no, not even star, just app state dot render device, right? Frame is used fences is a part of misc. Miscellaneous is not even a part of anything yet. So we will move the whole struct to the top because miscellaneous is used by the app state. So we won't move it all the way up, but we will move it somewhere closer to the app state's definition. So there we can say that this holds a misc data, right? Which in init, it will init. It will take the render device in as an input as it requires it. Similarly, at cleanup, it knows that misc data dot cleanup needs to happen before render device. And here's a little bit of that dependence problem. So we will say inside cleanup with do device wait item, right? Before we start anything. Misc will go away. So the cleanup for that will happen soon enough. In reality, it is in fact better to say we wait before we clean up anything. This will still work. This will be doubly safe. And on cleanup, we don't really care about performance. We don't actually care about how fast something shuts down, right? It is always going to be faster than, I mean, it'll be fast enough no matter what. So misc data, again, we'll take it out. So misc equals app state dot miss data, and this becomes misc, right? Frame index again, misc. It's not a part of it, but it should be. Create field frame index, right? You int 32t. Voila. So frame index has been created inside init, inside miss data init. We will say frame index equals 0. We'll just do it right here. So frame index equals 0. No problems. In app iterate, we need device, which is render device dot device, and we're done there. Image acquired semaphores, part of miss. Yeah, it's mostly going to be now copy pasting. Device dot device, render device dot swap chain, render device dot device, render device dot device. Command tools are in misc. Misc again. Acquire render device also part of misc. Part of render device again. Misc, misc. Chain views, render device. Okay, extend device. Misc again. Device. Okay, extend that. There, there. Triangle pipeline, part of misc. Render to present, part of misc. Render finish semaphore, also frame indexing. Direct queue is a part of render device. Blockchain is also part of render device. Direct queue render device again. And that's it. No more errors here. So that looks complete-ish. We don't need any of this. So that's nice. Build solution. Let's see what the issue is. Not all control paths return a value. 4 bytes of padding here because of uint32 being there. We'll rearrange to back. We'll let the warning happen, right? That's fine for us for now. You can just pack both of those quite easily in this particular system, but yeah, leave it aside for now. And we are not doing anything with the events at the moment, so no reason to keep bothering with it. Same with the result here. And it hides class member because we didn't remove this. Done. STL app event must return a value, return STL app continue, app Grid one. This is app iterate, which also must return continue, by the way. And app init must return continue. Solution. One succeeded, even though there are errors. We can see if it actually does a triangle. It does not. What failed? Swap chain create info swap chain. Retry. Okay, what's your problem now? Any debug information? Nothing printed here, so we shall use nicer things. Vulkan configurator. Run it again. No info here. Retry. What does it return? This is one of the small issues, I suppose, of VK check. Hmm. I'll stop it. I'll go to VK check. I will change it to define, not define actually, but a function. So I'll change this to void abort if field VK result. So here I can do assert. Not even assert really, I can actually just do VK check. Check on the result, and this allows me to just have the check available whenever we go for it. There's a way to actually get the caller's name as well, but I'm going to skip that for now. So bot if failed, this we can check. This is in line. To hint the compiler that we want to inline this, nothing other than that. And for each instance of VK check, we'll replace it with a bot if failed. Not this one, not this one, but everything else. No more found to the point where even these are gone. Check, that should be fine. Build solution. We succeeded, run, retry. That's where the breakpoint is. Error unknown. Why is there an unknown Vulkan error on swap chain, no less? Let's look at the call stack. Device, render device init. Any problems with this? Shouldn't have any problems here. It's not even a problem with the window itself. The window exists. Thanks, man. Thanks for the compliment. I'll take it. I'm just sort of doing my work and I kind of like showing it off, let's say. Okay, VK success is 0, VK error unknown 13. Some unknown error from swap chain creation. Oh, wait. Swap chain image count is 16? Why? Restart again. Let's see. Why is swap chain image count 16 ready? Capabilities max image count is 16. That is max. Swap chain image count is infinitely high. Yeah, it's because we stopped having the defaults. So swap chain image count equals 3. That helps us actually find the right number of swap chain images that we would want, and the actual number gets fit in later. Okay, that is also an error, but we'll see why that error exists. It's a vector resize error from here. We ask for resize, we ask swap chain image count, size of resize. So what's wrong with that? I don't get it. What's wrong with this? Exception was thrown. Val was an invalid value. It's trying to exchange val with something, but we're not using exchange anymore. This seems extremely unlikely. Okay. So what's your problem now? It's trying to move. That's why it's using exchange. Resize. New with the value init tag. Which is step in, new val, and val. We can let's do it again. Okay, so we had the val and old val. New val is 0, old val is loading symbols for additional information. Container proxy pointer. Yeah, that makes sense. This is internals of vector. I shouldn't need to debug this. It's literally a part of standard library. So why is it that it has an issue with this? The image count is p. Those are null pointers. These are defaults. Okay, that could be an issue. Unlikely, but it could be an issue. Yeah, that's not it. See? Okay, that is a possible issue. We are addressing something in this resize that doesn't exist. So swap chain images might not belong. The memory might not be valid anymore. Why can that be? That's if render devices don't have a valid memory anymore. But why will that be? Gee. Almost makes me think I should have used pointers. Hmm. That should be the size, but is this modified in some way at some point before this? Chain images. It doesn't seem like it is. You can look at this option image value when we debug it. So we come here, swap chain images, size is 0. Cater has some weird allocations. It should be something invalid, but 0C0C is rather weird. But going in, so we go in here, at least to that exchange problem. Okay, let's check something else. Size, percent, and then U. It printed the size. There was no problem with that. It's only once we came to no, it's a debugging. And it's still invalid value that is trying to move in. This I don't get. Why is STL giving me pain here? Why is vector giving me pain here? Have I done something that wasn't standard? Any kind of resize of this swap chain causes trouble. As it tries to orphan all, that fails. Change the array. Hmm, that's an absolutely unexpected issue. This exchange, that obviously cannot be an issue. It's an orphanal custom allocator problem. That doesn't seem like the issue I'm having. Constructor is skipped. Why would the constructor be skipped? But we can do that by doing this. This will force it to move in a new vector, and that one will definitely have the constructor to it. But it's trying to delete the old one. Oh no, 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 no. We are in render device, yes. So render device. It's default and okay. I know the issue. It took a little bit of effort, but I have found the issue. It stems from using vectors. So, one of the things I forgot when I moved to vectors was that I was still using malloc. And vectors are classes and malloc does not work together. So, app state in fact requires you to have a constructor here, which will be assigned there. This is fine. Look for other mallocs. So malloc, there is none. I look for free, and there's going to be one free, which is now to be changed with delete. Right? Nothing big, really. It's just that it needs to call the default constructors and the default destructors. Otherwise, it won't work. And there we go. We have our triangle again. So everything's working. This is one of those things where you have to pay attention to. Oh, yeah. Since we weren't handling events, close doesn't work anymore. So we will go and handle events. SDL app event, SDL app event, if SDL event, event dot type equals SDL event quit, return SDL app success. So that will just tell SDL, hey, successfully quit the app, right? Sorry. So if I quit it, there we go. That's it. That's done. Now, one of the things we do need to take into account is we have decided that our memory pattern will be the C++ one. We are going to use new, we will be using vectors. So now we must also consider using constructors and destructors. But, you know, for next time. Good night, good luck, and have a good week.